Okay, everyone. Well, thanks for attending today. This is the open source at CJUG session on Kotlin and Apache Groovy for October of 2020. My name is Josh Juneau. I'm here with my co-host, Bob Paulin, and also Mary Grogliski for the CJUG president. And we are going to first go through the opening about us, and then we'll go ahead and dive into some Kotlin first, followed by some Apache Groovy, which is going to be presented by Bob Paulin. So I'll go ahead and introduce myself for those of you who don't know. My name is Josh Juneau. I'm primarily focusing on Java, Java EE, Jakarta EE, Java SE. I work a lot with databases, especially during the day. My day job, I am a database administrator as well for Oracle, primarily. I do lots of authoring, not so much presenting anymore. I try and present a few times a year, and I am on a number of podcasts for the Java Clubhouse Network. Also, I'm a JCP member, Apache NetBeans committer. I primarily work on the Java and Jakarta EE support there. And I also do some work for EE4J and the JSF or Mohara specification there. I'm a CJUG board member, and I attend the Chicago Java Users Group sessions whenever I can. So that's about me. Bob?
All right. Hi, everybody. Bob Paulin. I'm an independent consultant here in Chicago, CJUG board chair, Apache Software Foundation member, Java champion, and also on a number of the Clubhouse Network podcasts with Josh, specifically off Heap, Java Clubhouse, the original with myself and Freddie Gimme, and open source at CJUG. So also breaking into open source, which is the podcast we run on open source. I am involved in a couple different open source projects, Apache Tika on the PMC and Apache Felix as a committer. Yeah, looking forward to talking a little bit about open source languages today with my friend Josh. So hoping that you'll watch today's presentation and kind of get a little bit of feel for the languages, but not only that, but also getting involved in the languages, which is one of the biggest things that we try to encourage here at the Open Source Initiative.
So we're going to go over just a little bit about open source development with Kotlin. I'm going to go over a basic overview. We'll talk about using Kotlin in some projects, and then a little bit about how you can contribute to Kotlin. So basically, we're going to talk about the history first. And to start off, just so you know, Kotlin is a statically typed and cross-platform language. It does compile to Java, JavaScript, or native, meaning you can go ahead and write Android applications with Kotlin. And as a matter of fact, that's one of the preferred languages for developing Android applications. And just a little bit of history, that this project was started in July 2011 by JetBrains. It was then open sourced in 2012. And, there are multiple different ways that you can work with Kotlin. And one of the first ways to work with Kotlin was through JetBrains IntelliJ IDE. But now there are other ways that you can work with it as well. There is a compiler that you can download, and you can actually have that running on your machine, and you can use the command line interpreter, which is what I'll kind of show you a little bit about today. Another way would be to use just a text editor. Lots of the text editors today have plugins that will allow syntax highlighting. One of my favorite text editors is Atom, and that's pretty much cross-platform, I believe. You can get it on just about any platform. And I use the Kotlin plugin for that. Also, there's a NetBeans, which is the IDE of my choice. Now, I'll mention, though, for NetBeans that the plugin is quite old. Now, the Kotlin plugin, I don't think is being developed any longer, but it is open source. So you can go ahead and start to work on that Kotlin plugin if you so choose to. That would be one way of contributing to Kotlin. So I'm just going to go ahead and give you a quick overview real quick here of some of the syntax in Kotlin. Very, very much like many of the other scripting languages for the JVM, the main focus was to try and make a language that was more concise and easier to develop with, and streamlined and also functional. So Kotlin does all of this quite well. And as a matter of fact, it has probably become one of the most popular scripting languages, if you'll call it that, or I like to call it alternative languages for the JVM. So one of the things is that semicolons are optional in Kotlin, and variables can be read-only or mutable. And you'll use the val keyword when you're defining a read-only, or the var when you're defining mutable. Data types are listed after the variable name. So as you'll see in the code that I show, we have, like in a constructor, you'll first include the variable name, then colon, and then the data type. Classes are final by default, and members are public. And this can be procedural or object-oriented. These are just a couple of the things that are different about Kotlin. Now, installation options. Like I had mentioned before, you can download the compiler, which is what I did. On the Mac, which is what I use, there is a DMG that you can, or excuse me, actually, there is no DMG for Kotlin. You download this, it's a zip, and you unzip it to your directory, and then you'll have to add it to your bash profile for OS X. You can also, like I said, get IntelliJ, NetBeans. Eclipse also has a up-to-date compiler for using Kotlin. And so just to give you a little bit of background too, Kotlin does release new updates quite often. And so there are differences between the different versions of the language, obviously. As it evolves, obviously, when you've got an older plugin, like for the one on NetBeans, there are some features that it's not going to support, right? Right now, one of the newest version is Kotlin 1.14, I believe. And this actually has some of the newest features that NetBeans does not support. Another great way to install on Mac is SDKman, Homebrew, or you can use Snap if you're on Ubuntu. Like I said, I used Atom for text editing, and then I use the command line interpreter. There are also tools that I'm going to show you that you can compile to an executable jar or run as script. So this is usable as a scripting language as well. So let's give you a quick demo here of what we could do with the command line interpreter. So I've already installed Kotlin here on my machine. I used SDKman to do the installation. And then once I did that, I did have to add it to my bash. But if I type in Kotlin C, that will open up the command line interpreter. And actually, my version here is 1.4.10. Sorry about that. I got my dots incorrect. You can see here by default, it's using JDK 1.8, which is probably not the best, but that's my default JDK on my Mac. So you can also use newer versions of the JDK though, so never fret. In this case, what I wanted to do was show you Atom, because this is one of the text editors that does support Kotlin. Can everyone see my screen still?
Yep. Good.
Okay, perfect. So when I clicked away, it must have shut that off. Now you can see in my command line, I'm running the command line interpreter. And I have also got my text editor, Atom, here. So when you define a Kotlin script or a Kotlin file, most of the Kotlin files are written with the extension of KT. This would be a regular Kotlin file or a class file. And there's a difference, though, if you want to run it as a script. If you want to execute it as a script, you have to use the .kts extension. And there are some differences here, and I will show you that right now. So what I have in this first window is hello world.kt. And all I've done here is I've defined a function, and I've named it main and put a variable and then a print in here. And one would think that you could try and execute this from within the command line interpreter, and it would just go ahead and work, but that's not the case. Actually, what you have to do is run it as a script and then call that function in order to get this to actually print hello world. If I were to run this, it would not do anything. One thing I can do is I can actually put this into a jar file. And the way that you would do something like that would be to call upon Kotlin C and then compile this into a jar by specifying the include runtime -d and then name the jar file. It looks like my, for some reason, tab here is kind of frozen up. Let's see if that will get me in. When I'm exiting the command line interpreter, it does not like that. That's interesting. Okay. So I will just type out the syntax. So as you can see here, Kotlin C, if I wanted to have a file that was named hello, I could do hello.kt and then include runtime and then do a D hello jar. And now that would create me a jar file, which would be then executable. And I could go ahead and run that jar file and it would say hello world. So just to give you a couple of ideas of what we can do, I'm going to drop into this command line interpreter again and show you some of the syntax. Now, hopefully you can see my my editor big enough. I'm not sure if I can actually increase the size of that font or not. Is that any better for you?
Yeah.
Oh. Yep, it's getting better.
Perfect. So what I can do here is I will show you the difference between some variables. So if I do the val a, I'll make this an integer and I'll assign it to 1. This is an immutable. So if I try and do a plus equals 1, I'm going to get an error. But I can actually use var b, and then I'll say b. And now what you're going to see is that the b actually will work, because b is now a mutable variable. You can also include something that's called top level variable. So let's say I want to do this top level variable outside of a function. Function keyword is fun, as I'm sure you have already seen from what I've shown you. And this particular function is not going to take any variables. It's just going to run. And it's going to variable I've actually presented on the outside. So if I run that function, it's going to print 7. Okay, so top level variables can actually go and be used inside of functions. Functions can be declared, like I said, with the function keyword, and they can be followed by parameters. So if I had a parameter that I wanted to type, I could do the name of the parameter and then the type. And actually concatenation for strings is plus, as long as the first portion of that concatenation is a string. If you have an int first, it's going to treat that as a actual operator and do the plus. So if I want to call this now, I can say hello. Whoops. Hello CJug, and it will print that out. Okay. You can also do something that is quite nice, which would be to provide a default for this. Then I can call this without passing it any variable at all. Comments are comments, just like Java has. Use the double slashes, or you can use this type of a comment and do the trailing as well. There are conditionals that are very much the same as you have in Java. You've got, the if and the else. Not much different there. Same with most of the other types of looping. You've got the for loops where you can iterate over lists in much the same way, and a while statement, much the same way as Java or something like Groovy, like you will see soon. There is something I'd like to show you, though. It's called a when expression. So in the case of the when expression, let me just clear this up here a little bit. So if I have this function I'll call describe, and we'll make it any type. It's going to return a string. This is kind of like a switch statement. So we're going to say when string is 1, then we're going to print 1. When it is hello, then print greeting. So with the when, it's very much like a switch. As you can see here, it goes ahead and it will fall through to whichever the evaluation equals true. Okay, so let's take a look real quick at classes. Classes and inheritance work very much the same way they would in Java. If you want, though, to use a inheritance on a class, you have to declare it as open, because classes are inherently final by default. So one thing I can do is let's make this class person. And actually what I'm going to do is I'm going to add a couple of variables in there. And now I can say val a equals person. And I can say a dot age. And it will print out the age. And so let's see what happens if I try and set the age. A dot age equals 10. And then I can print it out again. A dot age. Now it's changed to 10. Now what happens if I put a val for the age? If I declare it as a val, I'm going to get an error there. I won't be able to change that age. So that's something that's interesting as well. Something I wanted to do here real quick is show you, you can actually use this in quite a few different ways. One of the best ways that I found to use is to make use of it with Java EE, because I like Java EE and Jakarta EE, and you can really easily do this in a couple of ways. The easiest way is if you've got a Maven project, you can set up your Maven project to utilize the Kotlin compiler. And therefore, anything that has the .kt, any file with a .kt extension will be run through the Kotlin compiler, and it will compile to Java. Okay. The other thing you have to do here, if you're planning to do something like this, is to use the correct plugin for your environment. In this case, I need to use the JPA plugin because there are certain features that need to be exposed for Kotlin to be able to work correctly. For this particular example, I'm going to run through real quickly here and just show you. This is what you would see your path would, or your file would look like if you're making a JAX-RS configuration file. Very much the same as Java EE. not too much more concise, but where we get to see some cleanness is with the entities. Kotlin has this type of class called a data class. And if you have ever heard of Lombok, which has a data type as well, is very much the same. This will automatically create the getters and setters and the toString and that equals and hash code for you. And so my entity class here is quite short because now all I'm doing is actually declaring the different variables for my class. And if I look at the actual JAX-RS resource file, we can see it's very much the same as you would see with Java EE. One thing I have to do here is if I'm injecting any CDI resources, I do have to set them up as late init. And that's because this will give you an error if you compile it and it's not, it's null. And we know that the injection sometimes takes a little bit of time. So late init is how you have to declare that. But otherwise, you can see another thing I'm doing here, which is Kotlin specific, is I'm checking for nulls here. That's something you can do with Kotlin as well. So I've kind of gone through this, and I've showed you what I can do here with Kotlin. There's a ton to get through. I'm sorry I missed half of my time because I was muted. But what I wanted to go through really quickly here was just a little bit about contributing to Kotlin before we ended the session here. So let me bring your attention to this online event, which is occurring next week. I didn't go through too much Kotlin today, but you can actually learn a lot about it next week at the Kotlin event. So that's something you can attend online for free. And something you can see here is you can run through the tutorial about Kotlin right on the website. Very good. Go through each of the different features. And there's actually these things called cones that you can run through, which is basically, it gives you a test and it's asserting the test, and you can do it right in your browser so that you can see your tests running correctly or incorrectly. We can actually also work with this Kotlin playground right in your browser. If I want to change this and say CJUG, it will change right in front of your eyes because it's magic. It's actually compiling to JavaScript and running in the browser. But that allows us to test Kotlin without installing anything at all. And something you probably noticed when I showed you this is that you can edit this page on GitHub. So that's one of the many ways you can contribute to Kotlin. And you can also go ahead and get the sources by going to GitHub and pulling down the Kotlin sources. And one thing I wanted to mention here, when you're building it, you do have to have lots of different JDKs. And if you're on the Mac, you'll find that it's kind of hard to get JDK 1.6. So there are some ideas and some tips on how to do that here on the build page. And it does build with Gradle. So that's an interesting note to have as well. There are also lots of other Kotlin tools and libraries that you can contribute to. They're all on GitHub. Now let me open back up here to the slide presentation for just a moment. I want to thank you for bearing with me today on this. And so, like I said, you can play and learn with the Kotlin, playkotlinling.org, the tutorial, the cones, and then contribute by also giving feedback. You can try out the early access releases, the compiler. Everything is open source. You can contribute to any of that as well. Create libraries or do talks like this or training and tutorials online, because the more we've got, the better it is. Like I said before, this has been out since 2011 though, so it's not very hard to find Kotlin resources online. It's quite a popular language, and I think if you go out there and you're interested in doing something, you'll probably find an example for it. And like I did with the Java EE stuff, it's quite easy to get that going because lots of people have done it. So if anyone has any questions, I could take those now, or we can go ahead and wait until after Bob's session. I can hand it off to him.
Just a quick comment. So now we know where Java gets its ideas now. I'm just kidding. So you have a record similar to a data class, and then you have a switch expressions like a when.
Hmm.
So how does it work in the future? Like, for example, right now you use this for Java EE, but now would you be able to use record if you upgrade to Java recent version?
That's a good question. I think that probably in a future version of Jakarta EE, records will be usable. Right now, I think I'm not sure if that would work because one of the main issues that we have with Jakarta EE and running newer versions of Java is that you've got to have a container that runs on the version of Java that contains the features you want. And so lots of people are still running Java 1.8 or Java 8, I should say, because um, lots of the features are there and most of the containers are compatible with 1.8. A few are compatible with JDK 11. I don't think any containers have been made compatible with JDK 15 yet. So you probably can't use records yet. That's something that will be coming in the future.
In terms of Kotlin, I can answer that. The Kotlin team is working currently on supporting records in the Kotlin language, but that's a JVM specific feature. So they're not sure exactly what that's going to look like, but they'll have to add something to the Kotlin language or libraries to allow you to leverage that new JVM feature.
Thank you.
A quick one. Are there any downsides of Kotlin? I mean, kind of bad parts. It's been developed quite aggressively, as you mentioned, so that's probably one of the issues that you have to update fairly quickly. But from your experience, are there any things that they still trying to improve? Any things to be aware of? Well, the reason is before I start learning it, I need to understand why do I have to even use Kotlin. So I need to be aware of good parts and the bad parts, and even understand why I should start learning it.
Well, I'm going to be the first to mention that I've not used Kotlin for very long, so I may not be mature enough in Kotlin development to answer that question. Maybe somebody else out there on the line has used it longer than I have. Will be able to answer that better. From my perspective, though, the thing I've seen that has limited people is that it doesn't have the best support in some of the IDEs. So I think IntelliJ obviously has the best support for Kotlin. If you're not using IntelliJ and you're using something like NetBeans, you may have some issues because you're going to have to use an older version of Kotlin. It's not quite supported with the newer version on the plugin that's available. So that's the biggest hindrance in my point of view. Other than that, it's a very concise language. It's easy to use, and it's widely used at this point. So I do think it is an open source and is another plus. So it's a good language to learn, just to have in your toolbox.
I can take a stab at that one as well if you want.
Sure, thank you.
Yeah, so you're right on the money with the IDEs, and I think another thing is that because Kotlin kind of unlocks more functional programming aspects than Java does, you have to kind of make sure your team is on board with that, because if people really start going down the road with functional programming and other team members are not as used to it, it could make things actually harder to understand, just if they're not familiar with it. So I've seen that trip people up before, that the coding style changes. Because when you start with Kotlin, usually you're just writing Java-like code in Kotlin, but as you learn it more, you start learning more of the idiomatic ways to express things in Kotlin, and your style changes. And then the big thing that they're working on in Kotlin right now is around the multi-platform story. So Kotlin can compile, as Josh mentioned, to like JavaScript and native. So getting it working in iOS and cross-compiling between native JavaScript and JVM is still a little bit rough around the edges. And so they're working on making that better. That's what a lot of their effort has been going to recently.
Nice.
Okay, thanks. One more question, if you don't mind. How about the unit test support in Kotlin? How good it is? I agree that is a good point. Your team needs to be ready for that. But can you still have a project develop in Java and maybe start writing unit test or integration test or any kind of test in Kotlin? How hard it would be?
I believe you could go ahead and start to write tests in Kotlin if that's what you so choose to do. John?
Yeah, absolutely. You can have a project where one class is Java and the next class is Kotlin, completely intermixed. They play well with each other. Total interoperability. I use Jupyter JUnit 5 as my testing engine. I just write the tests in Kotlin, so that works completely seamlessly.
Great. Yeah, maybe that's a good start. Yeah. Okay. Yeah. Thank you.
Definitely. Thank you. All right. Well, I appreciate all the questions and thank you to everybody who participated. And I'm going to go ahead and stop sharing my screen. And we're going to hand this off to Bob so we can learn a little bit about Apache Groovy.
All right, so I'm going to be sharing my screen now. Hope everybody can see it. I've got just the Groovy main website, and I'm going to be taking just a slightly different angle than Josh, but a similar approach. So Apache Groovy has been around now since 2003, I believe, is when it was released. So it's a much older language than Kotlin. So the good thing about an older language is a lot of the tutorials and a lot of the use cases and the rationale for why you would want to use Groovy is already out there. It's already in tutorials. So I'm not going to go through and cover all of the kind of syntactic sugar and things that Groovy brings to the table. What I am going to talk a little bit more about is the language and the governance and sort of the evolution that you can do getting involved in hacking languages and having an open source language. So one of the differences, I would say, between Groovy and Kotlin are actually more around governance, as in addition to some of the technical things. So Apache Groovy, after being kind of a sponsored project by Pivotal, eventually Pivotal had decided they were not going to be the steward of Groovy, so they were looking for a home. I actually can't remember the year. I believe it was about 4 or 5 years ago. To which all of the contributors of Groovy came together and they selected the Apache Software Foundation as a new home for Groovy to continue to evolve and develop. And one of the interesting things you get with being in the ASF is the ASF's methodology with developing code and how their projects are governed, where the projects are essentially governed by the PMCs, so the Project Management Committee, and the committers. So this is kind of unique to languages. It's the only language that at least I'm aware of that's at the ASF and under this governance model where the contributors really are calling the shots. With Kotlin, you have the excellent stewardship that JetBrains is providing it right now. With a language like Go, you have stewardship through Groovy. With Java, you have stewardship through Oracle. So in most of these cases with languages, there's companies and management structures in place that only allow really a select few that are working for those companies to have at least the commit rights or at least the right of refusal on a lot of these projects. With Groovy being in the ASF, it really comes down to the project management committee and the contributors. So now you have essentially a language that is being managed through the Apache way, which, if you're a contributor, if you're anybody, you can submit a pull request, you can gain merit in the project, and then you can basically grow into those roles where you're managing the language without leaving your company or anything else. Not that these other structures don't take outside contributions like Kotlin does, Java does. All of them have external contributions coming in, but the governance at Apache, again, is much, much lighter weight, in my opinion, than some of the other languages out there. So wanted to draw that distinction just kind of as a first thing of why you might look at Groovy as a language to try to get involved with in open source. The barrier to entry is probably going to be the lowest you'll find across languages just because of the governance model. So let's talk a little bit about Groovy. And again, if you have questions, the time to interrupt me is whenever you have that question. I'm going to be a little bit shorter than Josh, so this actually works out perfect. I kind of figured there'd be a lot more questions on Kotlin being kind of the hot language right now. So Groovy is a dynamic language, and one of the things that you see in Groovy, I'll continue. So Groovy is a dynamic language, and someone made the comment earlier that Java is basically stealing features from Kotlin, and Kotlin is helping drive Java development. Groovy has also played that role in the past. Groovy has these concepts of closures and essentially lambdas, kind of in the JVM in Java came derived from those features. It allows easy access to create DSL by removing a number of the kind of conventions that you have in Java with brackets and parentheses, where you don't need to use them quite as often as you would in Java. So when you read the language Groovy, a lot more of it is focused on the code that you're writing versus syntactical things that are required by the language. So Groovy tries to reduce those things. And we'll see some examples of that. The other thing that was also talked about with Kotlin is the compatibility with Java. So obviously Groovy is running on the JVM. Most Java files, if you just drop them in as Java files, can be compiled as is in Groovy, because the language spec is really looked at as an extension of Java. So any of the keywords and things that are already in Java, you can use all those things in Groovy as well. I'm trying to think what the exceptions are. There may not be that many. So when we dig into the project, we'll see that there's basically the language definition starts with the Java language and then just kind of adds to it with Groovy. So let's take a look at the Groovy project. So the Groovy project, I have basically downloaded it, and like anything in the ASF, it is available through GitHub. So if we go out and we wanted to take a look at, nope, that's just the release notes. That's the wrapper. Sharing my screen, I know that. Yeah, let me make this a little smaller so I can drag it. One of the annoying things about WebEx is it likes to get in the way every once in a while. All right, so Apache Groovy, here we go. So we have it out here on GitHub, and we have very simple instructions on how to compile it. So I have basically an Eclipse project set up here, and if I want to compile said Eclipse project, Groovy actually compiles itself with another tool that is based on Groovy, which is called Gradle. So the Gradle Build essentially builds the Groovy project. Now it takes about 15 minutes to build, which is a long time for a smaller software project. But when you're talking about building a whole language, it actually seems pretty quick. So my build Groovy script here that I have here in Eclipse, I'm basically running the Gradle BAT with my working directory, my Groovy directory. Clean dist are the two build goals that I would use to build Groovy. And this results in basically a zip file where I can download both the executables and any of the command programs that come with Groovy. So if we want to take a look at the output, let me refresh here and go into the Gradle Distribution folders. So we have, oops, that's the wrapper stuff. Target, distributions. So I'm able to pull down and just, it may be a little bit small to notice. I don't have the bleeding edge Gradle here. I took down a branch of it because I wanted to do some specific things. But this is the Groovy 2.4.19 branch. So I can bring down a tag of a released version and kind of hack on a version that already exists. But the result of my build is I get a zip file of the binary source SDK. And the binary is the thing that we're probably most used to using when we download Groovy as a language and program in it. So if I take that and unzip it, I get a Groovy binary here, and I have a number of commands. Now, Josh covered some of the commands for Kotlin. Much like Kotlin, Groovy also has a scripting shell so that I can show some of the things that I can do in Groovy. So if I do a command line here, and I do bin, grape is one of the command lines that is basically like a Maven, so I can download dependencies, the console. I want the Groovy shell. So Groovy sh gives me a Groovy shell. And from here, I can just type things in Groovy. So I can define classes in here. So if I wanted to define a class in Groovy, I can define a very similar class than I would in Java. So if I already know Java, I can define classes in Groovy. So here I'm defining a class foo with a method called bar that's going to print baz. So it's your common, hello world here for a class. When I enter that in, the Groovy shell is going to create that class, and now it's in memory, so I can define a variable that I can assign to that class. So if I do foo equals new foo, just like I would in Java, now I have an instance of foo that I can call. So I can do foo.bar, and it prints my method here. So just like that in the shell, I'm able to do kind of my basic commands within Groovy. Now, rather than going again with the tutorial examples, I want to highlight some of the things, the ways that I tend to learn languages, or at least some of the boundaries in languages, because once you get through the kind of basic tutorials, sometimes you want to try to see if you can break things or where the problems of a language are. And one of the best places to find that are in the tests. So when you're looking at the actual code of the language, you can find all of the tests that are associated with the language itself. In Java, many of these tests are called the TCK, so a test compatibility kit. Now, Groovy doesn't have like a formal standard associated with it like Java does with the JCP. But in that case, the tests are really what validates the standard for the language developers. So one of the interesting things that happened in Groovy, with it being a dynamic language, is you can add methods to a class at runtime. So that is one of the more interesting things you can do with Groovy that in Java is really not something that is encouraged at all by the language. There's ways to do it with reflection, and obviously Groovy is using those ways to do it as an abstraction over Java. But when you do that in Groovy, when you have objects that say, well, I can define it at runtime, you can have exceptions where I'm calling a method that hasn't been defined yet. So within my test for Groovy, we can kind of demonstrate that I've got my object here, my foo, and I want to call another method called something. Well, something hasn't been defined on that object yet. So I get an exception, no signature of method. But one of the interesting things I can do in Groovy is if I know I'm going to hit this case and I don't want this exception to occur, I can define something called a missing method So here, if I have a class A, I can define a missing method missing, that will give a result instead of giving you the exception. So it essentially overrides it. And so let me use my class A here. We'll paste it in. So now I have a class A defined. So if I do an A equals new A, and I get an instance of this, right now A doesn't have any methods. So if I call anything on A, instead of getting the exception, I get the result of the method missing function. So interesting things I can pull out of the test. And again, all this is in Groovy tutorials, but this is kind of one of the fun things you can do, pulling in and hacking the language out of your tests. Another kind of interesting example, and I'm going to go through this one fairly quickly, is if you're looking through tests, you can actually start finding kind of interesting evolutions that tell the story of the language. So, oops, not tight. We'll go into resource search. Yeah, come on now. Oh, my Eclipse does not want to do my shortcuts now. Fortunately, I think I have this guy up. Here's a case where we have an issue number assigned to this specific test case, and it's sort of one of the interesting ones. So here you have a script where you define two different methods on a class. So you have a bar method and a bar method, and then you have a function that takes a class and calls that method. Now, bar does not exist on the Java version of class. So we're calling a method on a Java class that does not have a defined function. But again, this is Groovy, so I can define these functions at runtime. So in the past, they had it where in a previous version of Groovy, this would actually print 1 both times. It would go off of the initial definition. And within the language, this was because they would actually, all of this dynamics that occurs in Groovy has a cost. So they would cache some of these functions that you would define and attach to objects so that it would be a little bit faster. In this case, the cache did not work as you intended. You attached it to class, but you're passing in 2 different types of classes that have 2 different definitions, and you're expecting a different result. Well, what they ended up doing to make this work, if you again search for the commit, I gotta stop hitting that, is they ended up adding some functionality that didn't just compare the fact that it was the class that was sent when it was a Java class, but it also found out whether those classes, the instances of the classes that were passed in, were exactly the same. So if they were different classes, it will cache it differently within the Groovy language when it's searching for which method to execute. So before this change was in there, it would actually, if you defined it twice in different classes, it would skip over it and just give you the very first one. So just kind of interesting ways of going through languages and seeing how they evolve. And, you know, this was, again, something that was submitted prior to it being at the ASF, but this is kind of the workflow of you know, hey, I found a bug, I'm going to fix it, I'm going to submit a pull request, you know, the Groovy PMC can then look at that pull request, either accept it into language, give feedback on it, and you get to the experience of starting to contribute to a language. Instead of just being a user of it, you also get to be a producer in that language, if that's something that you have an interest in. The other thing that you can do, and this was something I added just as a fun way to study the language, is Groovy has this command shell, right? So this command shell actually has a number of commands associated with it. And some of these commands are just really useful for working with the scripts. But one of the things that happens when you have dynamic languages is there's a lot of magic going on in the back. So sometimes it's fun to take a look and see what that magic looks like in terms of Java. So what I added here is this dump command, which actually runs a heap dump of what's running in the console. So I've customized the Groovy language to allow this in one of the subprojects. So if I go into the Groovy Shell subproject, I can define a command called dump. And that command dump basically just uses the hotspot to run a heap dump of everything that's in that running JVM. That is the Groovy console. So if I run this dump, and then I provide a file, so our heap dump dot, we'll do hprof since that's the typical extension. So we have a few things in here. Then I can use Eclipse memory analyzer. So that's an open source memory analyzer to open that heap dump. And we can kind of look at some of the things that are going on with those classes. So let's go, we're on the D drive here. we're going to look for Apache Groovy binary. Here's this, and here's our heap dump. So our little language customization allows us to drop a heap dump off of this from command line. We can go take a look. And I know we've defined a few objects. So I can look at, let's see, we had an object A, right? Maybe. Let's see. Oh, there's our object, right? So this is the class that we created at runtime. We can see that's in the heap. If we want to take a look at some of the things in our instance of the object, we can see how Groovy is managing some of the metadata. So we have this meta class implementation that has information about the class. We've got the cache that I kind of spoke about, static property. So these are all things that Groovy is adding to this object that we just don't see, but they exist in the JVM implementation of the language. If you're a Kotlin enthusiast, you're looking for ways to, kind of pick Kotlin apart to see what's actually happening in the Java memory model. These are just some fun ways that you can look at some of these languages and explore them if you're looking to take it to the next level of understanding, of actually just trying to understand how the language is working and what they're doing. So that's all I had. But if you have any questions about the language, again, my focus was very different as far as what I was trying to talk about within Groovy. But if you have any questions on Groovy, I'm happy to answer them as well.
So we have a question from Josh on the chat.
All righty. Here, let me pull that up. I'm trying to get
You? As
back
a
in that. Let me stop sharing my screen and then I'll get the, here we go. All right. Yeah, if you could read it to me, Mary. Sorry, I'm trying to keep up.
So Josh Austin, our newest helper at CJUG, has a question. As a Spring developer, what positive differences would Groovy bring beyond using Gradle for builds and using Groovy plus Spark in unit testing?
Yeah, so those are both great use cases for Groovy. So I mean, Josh talked a little bit about Kotlin for unit testing. And the conciseness of the language makes it really attractive for writing unit tests. Gradle, again, is a build language. Kind of is the opposite. It gives you more flexibility than, say, an Apache Maven when you're trying to just kind of do something really quick and dirty in your build. That quick and dirty sort of way is the other kind of use case that I use Groovy for, which is just kind of command scripting. So there's some commands that if I'm doing operational things, I'll write it in Bash. But every once in a while, it's kind of nice to have all the language and library support from the JDK and Java to do some of your operationalization. So I'll write a script in Apache Groovy sometimes for operationalizing things. But yeah, scripting is the other strong, very, very strong use case for Groovy. Also, if you were trying to build a DSL, so let's say you're trying to build like an adaptation to the Gherkin language where you were going to run test scripts. I mean, this kind of falls under the testing scenario again, but Groovy's conciseness also leads it to be a very good language for DSL building. So I would also look at it for that if you have use cases like that within your organization or on your projects. Does that answer your question? Or is there anything more you're looking for, John? Or sorry, not John. Is it Josh?
It's like
All right, cool. That helps. Thanks. All right. Any other questions?
Is it actively being developed? Oh, sorry.
No, go ahead.
Is Groovy actively being developed? Is that the question?
Yeah, what is the latest version, or is it?
Yes. So, I mean, the beauty of all of these open source projects is we can kind of look at the repository and see when the commits are happening. So the latest commit to happen within the language was 7 hours ago. So some of it is, hey, I'm just removing updated Java content. There's new versions of Java coming out. So some of the modularity things that were introduced in Java 9 have been adapted to so that you can use those in Groovy. The other thing that we're seeing, so as Java is adopting some of the Groovy syntax, There's actually some active work, and you can look in the JIRAs at the ASF to actually modify the implementations in Groovy to use the native Java implementations that Java has now taken on, which should make Groovy more performant and efficient since it's using things that are now built into Java. So
Yeah, like
yes,
closures and stuff, or
exactly.
at least Java calls Lambda, Groovy call closures. I think it was inspiration for that probably. That's
Absolutely.
how I think. Also,
So
on the side note, XML processing, if somebody's still doing it, I mean, I don't know, 10, 12 years ago, I discovered Groovy had excellent support for going through XML.
XML and JSON. You know, some of the latest things are, you know, you used to be able to do within Groovy, you could do kind of that, those inline text blocks. That's something that's coming into, I think it's JDK 15 is adopting like text blocks now too, so you can even, you know, drop entire blocks of text into your code rather than doing
multi-line,
let's
multi-line
concatenate,
strings.
yeah, let's concatenate a string about 3 dozen times. So that's also being adopted by Java, and I expect, you know, as those things are adopted natively in Java, Groovy can be adapted to use the native Java since it'll probably be more efficient.
Sorry, quick one. How easy it is to integrate Groovy? Because you showed us the Gradle example, that's fine. How easy it is to integrate Groovy into existing Maven project to avoid any clashes, any problems with the existing plugins supporting Java?
Yeah, so I think it depends on sort of the runtime of your project. Sometimes it's completely seamless, right? I have seen some struggles with Groovy projects in OSGI environments where you're trying to use Groovy things reflectively that are being blocked because of access to classes that are protected. And, you know, in that case, it's really OSGI is doing its job to prevent access to those classes. I mean, the same could be true of, you know, JDK 9 plus with the modularity where, you know, a lot of the reflection becomes more restrictive. So in those cases, you know, Groovy has a very open sense of what it should have access to compared to what the JVM is saying it can have access to. And at the end of the day, the JVM wins because the JVM is what's enforcing reflective access at different versions of Java. But as far as integrating into a project, you know, it compiles to class files. So if you have separate source directories in your Maven project, for example, you can compile Groovy and Java into the same jar without any sort of problem. You know, you need obviously the Groovy runtime dependencies to execute it, since there's helper methods defined in the runtime. So you do have to add the dependency. But outside of that, it generally plays fairly nicely in my experience.
Okay, thanks.
This is Josh. I would just want to mention it's probably very similar to what I showed you with the Palm and the Kotlin support. Just plugging in that compiler, that dependency, that would probably do it. Can I mention one more thing, Bob?
Yeah.
Okay, I just wanted to mention for those of you who are using Spring or other web development APIs and you want to use Groovy, there used to be Grails, but Grails really is no longer actively being developed, I don't believe. Maybe maintained, but not going to be adding features, I don't believe.
Yeah, I think that's fair.
Yeah.
I mean, it is slowed down significantly.
Sure. And so if you're interested in developing some kind of microservices or web applications, Micronaut would probably be a good option for Groovy. And I think Micronaut also supports Kotlin, if I'm not mistaken.
I think that's true. You know, and that's a good call out, Josh. Not mentioning Micronaut is kind of a disservice to talking about Groovy, since that has kind of been the folks that created Grails kind of were the driving force behind Micronaut as sort of one of the next step forward for Groovy developers. So yeah, if you're into Groovy and you're into web development and you want to try to use Groovy more full stack rather than for specific things, Micronaut is definitely something to check out.
Quick one. From your experience, because we have so many different scripting languages, right? We just mentioned a few, right? You can choose from probably too many, but from your experience, do you have a use case that you used Groovy as opposed to Kotlin, Java, Python, etc.? Because the Groovy was the best tool to do the job.
So one of the examples that comes to mind is, and I never actually tried to do this in Kotlin, so I may be making some assumptions on what is and isn't possible in Kotlin. But we actually had a use case at CJUG with getting folks' names to the security personnel at the meetups, because your entry in the meetup didn't always have your full name. Sometimes it was only a partial name. So there was different fields in the Meetup API that we could pull from to create your full name in order to get your name to the security folks so that they weren't, calling us while we were starting the meetup. So the Meetup API required some authentication. It required some JSON processing to kind of tease things out. And I didn't really feel like doing it in Bash because we're the CJUG, we do Java. So one of the things that that I shouldn't say Gradle, that Groovy offered me that I couldn't get from Java or from Bash necessarily was the one of the things that I didn't talk about in depth, but I kind of mentioned very, very quickly, which is Grape, which is the dependency manager for Groovy. So one of the cool things that I can do in a Groovy script that I'm not certain I can do in Kotlin, and I definitely can't do in Java, is I can add these grape annotations at the top of my Groovy script, and it basically looks like Maven coordinates for dependencies. So if I wanted just to pull in Jackson, or I wanted to pull in a few small libraries, I could use a grape grab to go get those libraries and embed it in my script. So I don't need a POM file. I don't need anything except the Groovy runtime and my script. And I can do a very, very powerful small script where I was doing JSON processing. And you don't need Jackson for Groovy. I was just playing around with it. But the ability to use some of the Meetup APIs and pull down the dependencies so I can just access things that were already written in libraries was very, very powerful. And that exists in Groovy. And I don't know of another language that has that, where you can just literally throw dependency management in the script itself. So that was kind of cool.
Yeah, I agree. That's quite interesting. Okay, that's probably a good case for the Groovy. All right, yeah.
All right, and then, one additional thing I would point out for Groovy, and I'll put this in the show notes and maybe the chat real quick, is for that script, I use something called the Groovy Wrapper. It's very similar to folks that are familiar with like the Maven wrappers or the Gradle wrapper, where you don't have to actively have the runtime installed as long as you run a bat or a shell file. So this project provides an implementation where you just run groovyw.bat on Windows or groovyw on Mac or Linux, and it will download the Groovy runtime and execute your script with a single command. That was another thing that I ended up using quite extensively for the same CJUG script. So basically I had the script with all the dependency management. I used this wrapper that I pasted in, and I was done. So that was kind of a fun way to script things up. All right, well, that's all I had. If there's no other questions. All right, Josh, back to you.
Yeah, I just want to let everybody know we appreciate you coming and seeing the presentation and learning a little bit about Kotlin and Groovy today. And thank you, Bob, for the great presentation. That was great information, and I've not ever dove into Groovy much like you have shown. So that was unique and very interesting.
Thank you.
And Mary, I appreciate you pulling it all together and the WebEx
Thank
meeting
you.
and all that.
Yes, Mary with the save at the last minute.
No problem. Thank you, Bob. Thank you, Josh, for your presentations. So thank you. And thank you, everybody, for coming. So,
Thanks, everyone.
thank you.
All right. Thank you. Happy Friday.
Yeah,
Yeah,
you too.